Okay, so welcome to the second session of this week. I wanted to start with some modification of the deadline. Also, what I can do quickly is just check the previous venue. I'll just check the other venue if anyone is there by mistake, and then I'll be back. No one is there, sure. Oh, okay, perfect. Then that's taken care of. Okay, now I know we had a discussion yesterday about the Sri Lanka trip and the change of dates. And apparently, I did talk to Mariam, and she has confirmed that it is going to be 20th. Though she mentioned there are two groups, but again, I think both the groups are same week itself. Three groups, yeah. So it's in the same week, right? 2022 and 28 is the last one. So we discussed a possibility where we can say, okay, all the analytics students, go in a particular group. But I personally felt that's not going to work because, you have your choices of the dates and groups and so on. So we cannot force anyone to leave on a particular date because we have an assessment. So I came up with a plan and I have discussed this with the previous batch already, and looks like everyone is comfortable with the plan, but I need to check with you if there are any complications. So please listen very, very carefully. So right now, week number 5 is going on, which will finish this week. Next week will be week 6. Next week will be week 7. Okay. Now, week 7 for your batch, the mock hackathon will be on 15th. Okay, which is Wednesday. Yeah, which is during the class hours. So you get exposed to the mock hackathon. The main hackathon will exactly follow the same as mock hackathon. The only difference is new case study, new data, and so on. But pretty much, the structure and the complexity will almost be the same. So 15th will be your mock hackathon, and here is the big question that I need to ask you. What we are planning is to have the main hackathon on 19th, which is Sunday. The campus will be open. The lab will be booked. Both the batches will be doing the hackathon together. For anyone who needs transportation, it will be arranged on Sunday. I mean, who regularly take the university transport. So that can also be done. The only choices that we were thinking is, should we have it on Saturday or should we have it on Sunday? Come on. So we thought Saturday is better. We also checked with the other group. What Sunday does is gives you an additional day to prepare. So basically 15th, you are having your mock hackathon. So if the main hackathon is Saturday, then basically you have only 2 days, 16th and 17th, to work on the main hackathon. But giving additional Saturday will also help, particularly because 17th Friday, the other AI hackathon is also happening. So you will be consumed, you will be having spending some time over there. So again, keeping the preparation time in mind, Sunday, I think, looks a more logical option so that you get one additional day, preferably in the first half, so that, Sunday, second half, you can be free. So somewhere, I think 10 or 11 a.m. is when we are planning for the main hackathon. Sunday would be okay? Yeah. 40%. Sorry? 40%. That's a 40% assessment, correct. And this is a graded assessment. By the way, the online option is there, but the downside of it, you have to keep your camera switched on. The whole session will be recorded, and there is an AI tool that can actually figure out whether you kept your camera on or not. And again, if the camera doesn't work, then problems, then it's your responsibility, right? So better be on campus so that anything goes wrong, you can ask me, I can see what is happening. So it's much better if you're on campus, but by any chance, because the rules allow hybrid, if you are doing online, then the camera has to be switched on throughout your hackathon. So 19th would be the day. So that leaves, if we have one session on 19th, which is the main hackathon, that leaves us with one more class, one more 3-hour session. And what I'm planning is, once you're back from the trip, we can do a complete online session, which could be Q&A and feedback for your coursework too. So that could be the last session. Again, it's optional. If you have any questions, if you have any doubts, we can have one online session. where you can come at a specific time and you can ask questions about coursework too. So that can be dedicated to coursework too, so that after the trip you don't have to be on campus and no problems if you're traveling somewhere. So I think that's the way best we can manage the last week. Does that sound okay with everyone? Yeah. The other deadline remains the same, which is 31st, I think I have kept. 31st of July, coursework 2 remains the same. Again, there was a request from the previous batch, can that deadline be extended because you are going for a trip? So to answer that question, I'm okay with extending the deadline. The only problem is I'll have to check with Mariam what's the grade submission deadline for the business school. Usually, I need at least 7 to 8 days to go through all the 80 recorded presentations, give you grades and marking. So, I can adjust in 7 to 8 days, but we also have a deadline where we have to submit the marks. So, I will see if our deadline matches a bit of extension. There is a possibility I can extend by a few days. I don't mind it. But if it cannot be, then it remains 31st. So I can check on that. From my side, I'm okay. There's no hard and fast rule that I cannot extend. But remember, 31st is already a sort of extended deadline because it's almost 1 week after your last week. So I'm not sure how much I can help, but whatever possible, I would love to do that. If there's a possibility of extension, I can extend by a few days. Any questions? Yes. We gave them no classes because one class would be hackathon that you would do on Sunday. And the second class would be an online session once you come back. So no classes then during the week. Any other questions? Anyone has, please let me know. Anything that came up from coursework 2 or anything that we had a discussion yesterday? Yes, correct. So again, I'll see if the deadline can be extended. If it is not, then around 21st, 22nd, we can keep the draft deadline at least 7 to 8 days before the actual date. Yeah. Anything else? All good? Okay. Online students, let me know if there's any question from your end. Those who came late can quickly scan the QR code and then I'll close the attendance. Sorry?
Oh,
Yep.
I think save my this thing we did, but it's still like not.
No, it's all autosave. There's nothing that you have to save. Probably are you making the same mistake? I mean, if you can. Yes. Yeah, please. So are you checking your folder first of all?
Yeah.
Yeah. And when you search, tell me your name. Sorry. Siddharth. Yeah, I know. Sorry. Siddharth, this one, right? Yeah. So if you see and if you go back, yeah, there's Titanic. So guys, this is a mistake that everyone is doing. Please, again, be careful. So for example, Siddharth's folder, if I'm looking at, I go to project folder, I search for Siddharth and I click on the folder. I might feel that there are only two projects right now, but that's because SID is already being searched. Okay. So you need to remove that and make sure there is nothing that is searched and then you can see all the five projects.
So the Titanic, that one I've made right now,
Okay.
which I'm working on.
Okay. What about
The
Titanic?
not Titanic.
Ah, okay. So let's see.
That's the problem.
So what was the name given to your project last time? That you should, yeah, be careful on anything that you're making a project. That's why I said keep it in your folder so that you can always track back. Uh, do you you can do one thing. Mm-mm.
So that's not the April's part. Can they just show me that prepare recipe one that I'm doing?
No, or what you can do is So you can actually use my project. So if you search KD, you will see a folder called KD123. Do you see that?
Yes, sir.
And in that you can search Titanic underscore KD. Yeah, and you can just start using that. Yeah. Okay, shall we get started, everyone? Yeah. Any questions? Shall we get started? Okay, so let me get to the folder. You are using Titanic KD, is it? So I should be using Titanic. All right, let's get started. So to remind you of where we were and what did we do in the last class, we had our Titanic data set. We figured out which variables are important, which variables are not. Which algorithm are we doing? Do you remember? Is it supervised learning or unsupervised learning? Okay. Does it do categorical prediction or does it do numerical prediction? Fantastic. You guys are sorted. Nice. So then we looked at Titanic, we looked at all the columns, we figured out which columns could be helpful, which columns might not be helpful. Then we did a prepare recipe, we transformed the data, and then we have a prepared Titanic data set. And then we split our data into training and testing. What is the general thumb rule for training and testing? 80-20, you can play around. It can be 90-10, but nothing beyond and above that. Generally 80 to 90, you should maintain your training data. Great. Now is the time when we actually implement the algorithm. You have to be very careful because the first algorithm that you run, then everything remains the same for the other algorithm. So you must get used to where to give the inputs, where to see the output, where to see the predicted value and things like that. So again, it's a sort of learning curve. When you do one or two times, then it comes naturally to you. But till then, you should be very careful in your mind which option, where do you find, which name are you giving to the analysis, what name are you giving to the trials. You should be very careful in navigating the whole thing. And you should become an expert in reading the output. And that's why probably today's entire session will be required to see how to run, to play with the parameters, to understand the output, to see the mathematical parameters. But once you know how to do it for one algorithm, the next one is probably half an hour, 45 minutes job for you. You just need to know what the new algorithm is. Everything else remains the same. So shall we? Tell me in which folder or which data set should I click to apply logistic regression? Train, that's right. So let's click on train first and then see all the options which are coming on the right hand side. Now, here is my question. Do you see any recipe which says logistic regression? Not really, right? Check all the options. Do you see any recipe that says anything with machine learning, anything with AI? Yeah, there is a code recipe. Now, this is very, very interesting, and I'll touch upon it later. So now this is, probably the coolest part of data IQ. Let's say you're doing some way more advanced things, okay, which is not there in the tool. So what you can do after doing all this, you realize there is something way more advanced that you need to do. You can bring coding, and you can actually bring a Python code here in the form of an item. You can ask ChatGPT to fill in that code for you, and you can even run the code inside Data IQ for those who are interested in coding. But we are not going to touch upon that because already there is a lot of things that Data IQ can do. Probably I cannot think of anything that at this stage that the tool cannot do. So let's click on Titanic train. And when you do that, you see an option called lab. Can all of you see that option called lab? Yeah, click on lab. And now you would see some things related to ML. So you have auto ML prediction. For those of you who are interested in time series forecasting, basically what we did in regression was time series forecasting. Okay, but there are other methods other than regression, ARIMA model, this model, that model. Everything can be done here. The causal prediction, what causes something to the effect of another thing. Object detection. You remember that Google Teachable Engine that we did? You can actually build something like that inside Data IQ, image classification, clustering, so on. Lot of different AI models that you can run. The one that we are going to click today is Auto ML Prediction. And I want all of you to click on that. Auto machine learning prediction. Yes. Sorry. I think I've started the recording. Let's check.
Yes, sir.
Yeah, it's being recorded. Okay. Now, see the beauty of the tool. The moment you said auto ML prediction, it pulled out all the columns of your data set. And it is asking you, can you tell me what it is asking you? No? Think.
Prediction model.
Sorry?
Prediction model.
What do you want to predict? Exactly. There are a lot of things in this column, right? In this data set, you need to tell Data IQ, what are you trying to predict? Which column are you trying to build the model on? Can you tell me which column? So, right. So, and why this is an important step, based on the nature of the column that you select, it will recommend algorithms. For example, if you select survive, you will not see regression as one of the algorithms because regression can only help you do numerical prediction. This is a categorical prediction. So according to what you select, you want to predict, it will recommend the algorithms accordingly. So let's click on survived. Now it understood that you are creating a prediction model on survived as a column. Now it says, I can build some prototypes for you. I can build some automatic models for you. You can do deep learning algorithms. If you remember the conversation that we had, you can do basically anything. But right now, I am knowledgeable in the sense I know the algorithms. I can pick and choose the algorithms. I can play around. Other options are mainly for people who have no idea. Like, let's say you don't know anything, you just want to blindly trust Data IQ. It can still do some modeling and give you some answer. But right now we are knowledgeable. We know what we can execute. So what I would say is this one: choose algorithms. I will choose my own algorithms. Click on that. Now, the moment you do choose algorithms, it will say, please name your analysis. You can give any name. You can retain the name if you want, but let's give it a name. I can say survived model or whatever you want. Analysis one, you can give it any name to your analysis. And once you do that, make sure you have selected choose algorithms. You have given a name. You can retain the original name also, does not matter too much. And click on create. Has everyone arrived on this? If you can keep your screens active, I know all of your the stage. Nice, nice, nice. Fantastic. Great. Okay, now before we touch upon the input versus output, let me show you the navigation, and all of you should get comfortable with navigation. The moment we get into the analysis, it shows you two things: design and result. Okay. Now, in design, you can give a lot of inputs. For example, what is your X1, what is your X2, what is your X3? You still have to say that, right? We didn't tell which variables will help us find the survive. So you can mention that. You can choose the algorithms. Which algorithm do you want to try in your analysis? You can choose the training and testing strategy. Which one is your train data? Which one is your test data? All of those inputs are part of design. Once your design is done and you're confident that everything that you had to give, you give as an input. When you click on train, you will see the results in the results tab. So right now, when you click on results tab, you see nothing because we haven't run any algorithm yet. Whenever we keep on running, and this is the beautiful part of data IQ, everything that you do is all documented. For example, if you run it 10 times, right from the result of the first one till the result of the 10th one, all of them come in one space. Okay, so you can keep on running, then you can go to design, change something, again run, again come back to the result, again go to design, change something, come back to the result. Every time you keep on running, your entire history of the algorithms will be documented in this result tab. So two tabs to watch out for: design for the inputs of the algorithm, result for output of the algorithm. Okay. What else? Now, this top menu also comes into picture. So we were seeing only this part so far, which is flow and dataset. Now that you have entered machine learning, this menu also becomes important. So for example, if you click on the first one, visual ML, you can see the name of the analysis that you gave. Okay. When you chose survived and you gave a name, if you have multiple analysis, you can have multiple analysis listed here. Within the analysis, you can have multiple trials listed. So just make sure that you keep a track of how many analysis you're running. When you click on this, it will take you back on the same thing, design versus result tab. So I can keep going back and forth. I want you to get comfortable. So go back, see the results, and you would say, oh, there is one analysis here, which is survived model. And that will take me to the design/result tab. What happens when I see the flow now? You see nothing has come on the flow yet. And that's why this menu option is important, because when you're doing something, it won't appear as of now till you decide this is fine. And till you deploy the algorithm, till that stage, nothing is coming in the flow. Only when you're full and final ready deployed, then that deployed stage will be visible in the flow. So that's why flow is not quite important. This menu becomes more important now, where I can keep going back to my service, the survive model, and I can see the design versus result tab. So what do you think I should play next in? Design or result? Design. Let's go ahead. Tell what we want. Okay. How do we start? Let's start from all the left-hand options. Okay. The first thing it says target, and see the beauty of the tool. Because you told survived is what you're predicting, it has automatically figured out this is a two-class classification, correct? Which means survive or not survive. And it is telling you what you are more interested in. Look at target. Are you more interested in predicting survival, or are you interested in predicting not survive? That can also be the case. For example, in a bank, a loan default, are you trying to do the probability of a loan default, or are you trying to do the other way? So you can choose what is your target variable. In this case, I'm more interested in survival, which means whenever I see those probabilities, they reflect the probability of survival, not of not survive. So be careful, whatever you are interested in, mention that as the target. So in this case, it picked up correctly. Survived is what I'm interested in. And what else? What else? It shows how many are survived, how many are not survived, 0 and 1, which is great. All looks good. Target wise, we are sorted. Next, what do you think that is? After target, train and test. Now you have to be a bit careful here. Click on train and test. Now it says, what's your strategy of training and testing? What's the policy? Right now, the problem is by default, it is assuming that you haven't done the split already. So now it's saying, do you want to split the data set further? Which is not what I want. I've already done it. I have a train data. I have a test data. I just need to inform data IQ. Where is my train data? where is my test data? So let's look at the option. Let's click on policy. Now, question to you. Which option do you think I should choose? Check all the options, check the description, and tell me which option should I be choosing.
The last one.
Last one is explicit extracts from another data set. One use two extracts from another data set. Okay.
So second, third
First one, okay, two from Titanic Train, one from 10. Second one is explicit extracts from two data sets. Use two extracts from two different data sets, one for train, one for test. That's what we want. We already have one data set which is train. We already have another data set which is test. That's exactly what I want. I click on second. Bring data from different data sets. Okay. Now, observe carefully. In this case, this might not be a problem, but in a bigger data set, this will be a problem. Look at train set and look at what it is doing. It's actually sampling the train. Do you want to sample it further? No, I don't want. I want the entire train to be used as train, the entire test to be used as test. So ideally, in this case, it wouldn't make a difference because it's taking so many records as the sample. But why take risk? Instead of this, no sampling. Please don't sample anything in train. Similarly, please don't sample anything in test. Sorry, yeah, explicit data from two data sets. Third, so ideally 1, 2, 3. This is the option. Explicit extracts from two data sets. Use two extracts from two different data sets, one for train, one for test. Perfect. Now, train, has it chosen correctly? Is this the data set that I want? Yes, I already have Titanic train. Very well chosen. All good. And no sampling, please. What about test? Has it chosen by default? No. This is where I would say, please choose test. Where is test? There you go. Titanic test. And again, no sampling, please. Use full train, use full test. Don't do any more drama of any sampling. So just make sure that train is in train, test is in test, and you're all ready. Then no more drama required in training and testing. Okay, that is done. I've given some inputs. Let's move to metrics. No need to change anything. Debugging. These are all advanced options for those who are trying to do a PhD can look into all this right now. Not important. Next, features. Do you think this will be important right now? 100% yes. Why? Because what do you mean? What is the meaning of features? Variables, 100%. So let's click on features handling. And this is where data IQ is asking you, which variable do you want to push to the model? Which variable you want to exclude from the model? Remember, as I told, by technique, string variables cannot go into the model. So by default, it will be switched off. But others, it will never say that should you or should you not. That's your decision. If you send bad models, it will still run. It will still give you a result. And you might think that's a great result. But if you send bad variables, if you send correlated variables, you are heading to disaster. And this is where human decision making is important. And all the discussion that we had, whether class is important, whether gender is important, whether embark is important, etc., etc. Now we will put that to action. Why do you think survived the on-off button itself is not available? That's what you're predicting. That's your target variable, right? So there is no question of including that in independent variable. Why do you think passenger ID is switched off? It's a string, right? Or number or whatever. That does not make sense. So data IQ is smart enough to understand ID can never become one of your independent variables. P class is switched on by default. Should we keep it on? Yeah, we already saw how important P class is. Name, you see it says rejected. It's a text feature. So this is what AI is doing. It's automatically even recommending you what should go, what should not go. It understands that name should never go. Technically, it cannot go. So name is off. No problem with that. What about gender? Should we keep it on?
Yeah.
Yes, definitely, 100%. What about age? Now, those who had age categories can keep that on or keep it off. Let's do all age together. In the next run, you can do age category on. Okay. But don't keep both of them on. That will be a disaster. Either age or age category for uniformity. Let's keep age as of now. Don't switch on age category as of now. CBSP and PASH. Yeah, we were not sure, but we'll keep it. We'll see what the algorithm says. What about ticket ID? No, that is 100% off. I should not be taking ticket ID. What about fare?
So,
No, and we discussed the reason why. It is correlated with class. I should not take it. What about cabin? Switch it off again. I should not take it. What about embark? Again, no, but I'll keep it on just to see what importance data IQ gives for something which might not be relevant. And the good part is, even at this point of time, you can take some decisions. For example, when you click on embarked, you can see the distribution of embarked. When you click on gender, you can still see what percentage of males, what percentage of females. So it very nicely summarizes everything. And that does a heavy lifting job of figuring which variables should go, which variables should not go. That part is done. Type you cannot change. It has to come back from data. Not at this point. I don't think so. There is nothing much to be done in feature generation, feature reduction. Again, those are advanced things. Let's come to modeling. That's where we want to see what algorithms is Data IQ recommending right now. So you would see by default it has switched on logistic regression. It's also recommending random forest, which we will be seeing, but I will switch it off as of now. And here is the best thing about Data IQ. Once you know decision trees, once you know random forest, you can switch all three of them together. And with the same analysis, you can run all three algorithms and compare the results, in which one you got better results, in which one you got less accuracy. So you can even run them together if you want, but do that later. Right now, one algorithm at a time. We'll switch on only logistic regression. Okay, anything else? Yeah, I think pretty much looks okay. Again, if you want to explore some advanced things, you can. Now, here, once you have made all the changes, I would recommend clicking on save because you have given a lot of inputs to the design. So click on save. And once it is saved, then you can click on train. The interpretation to text. Maybe you missed that earlier. Can I check your data? Yeah, that's okay. And click on yeah. Yeah, see, it is. So we did it next. But I don't think that makes too much of a difference in the morning, but still try it out. Yeah. Yes. Correct. Correct. Correct.
Then why are we taking extracts for tests?
That's a good question. Everyone, please listen. So the question is, we said that we will be making the model with the train and saving the test for the test. So why did we have to at this stage tell that this is test, because once we click run, it will do that job for you also. It will take the test data, it will predict it for all. How many passengers were there in test? 170 something, right? For all the 173 passengers, it will do the prediction, it will compare with the actual data, and it will give you the accuracy all at one go. So we don't have to wait another step where, oh, now the algorithm is done, let me test it on test data. With one button click, all done, and you'll see that now. So if I didn't give test data at this point of time, that step will be incomplete. So right now at one go, I tell this is the test data. Once you have done the algorithm, test it on those 173 rows, do the prediction, compare with the actual result, and show me how many matched, how many did not match, all at one go. That's the beauty of the tool. Everything can be done in one attempt. Okay, now careful
Sir,
here.
I just had a
Yes.
quick question.
Go ahead,
Would you go once again from feature handling? You went quickly, so I just lost track over there.
No problem, no problem at all. So in feature handling, I switched off. Are you done with feature handling?
Yes.
Yeah. So I switched off ticket, fare, cabin, the ones that did not make sense. And then the only thing I did was algorithms. That's it.
And we turned off random forest, correct?
We turned off random forests. Only logistic regression should be switched on. That's it.
Okay, thank you.
Perfect. Okay, now guys, everyone, when you click on train, now you have to be a bit careful here. What was the name that we gave to the overall analysis? What I gave, anyone remembers? I can go back and check. So I go to Visual ML. There you go. Survive model is the name of the analysis. And listen very, very carefully. Within this analysis, I can do multiple trials. Okay. The one that I'm going to do right now is trial one. Which algorithm am I doing in trial one? Logistic regression, and I have some set of independent variables. Okay. Now imagine I finished trial one. I got the results. I saw the accuracy. Now I'm thinking, oh no, I should not have considered age as a variable. Instead of that, I should have considered categorical age. Okay. I can go back to design. I can switch off age. I can switch on categorical age and rerun the analysis. That will be my second trial, trial two. Okay. Again, I can go back to design and I can say, oh, I wanted to try random forest also. I can switch on random forest, switch off logistic regression, go for trial three. So I can have multiple trials within the same analysis. Overall, analysis is still the same, survive model, but every time I run, I can keep a track of what I was doing with trial one, trial two, trial three, trial four, so that at the end, I can decide which trial was the best model for my analysis. And once I'm convinced that trial two was the best one, I can go ahead and deploy it. The problem, if you don't give multiple names, everything will be written on the previous trial itself. And then you say, oh, no, 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 the first trial was the best one. Now there is no way to go back to trial one, right? So every time you are experimenting something, give it a new name, trial two, trial three, trial four, trial five, so that you can compare all the trials, select which model is the best for you, and then go ahead and do the analysis. So let me get again. So this was my design. I hope everything is good. Train and test algorithms, only one switched on. So I click on train, I give it a name trial one, and then click run. Or now this is where I'm keeping my fingers crossed, because when 40 of you are doing the algorithm run together, I hope the server is taking that. Okay. Yeah, it will take time because all of us are doing at the same time. But that's good enough time. In 5-6 seconds, if you're getting it. Oh, good. I'm happy. Server is handling this. Nice. Random data. So remember, all of you might not get the same results. Our data is random. Train is random. Test is different. So everyone is practically running on different data. So you might get different values, different results, etc. But hold on, we haven't seen the results yet. Anyone who does not see something like this, does not see a champion trophy, does not see the top variables, let me know. I'll be happy to assist. All good, you guys came late. Are you okay? Yeah? Yeah, all good, all good. That's it. Yeah, I tell you everything. Okay, now let's make sense of some of the things that you are seeing on board. Now, everyone, be careful. First things first, you see it says which models have you trained previously. Right now, I did only one trial, so you see trial one. The moment you do trial two, trial three, trial four, the entire history will keep on coming over here. Okay, which is a great way to go back, compare. Oh, this is what happened in trial one, this is what happened in trial two. Now, the most important output parameter as of now is this number that you see right next to logistic regression. And these numbers might be different because random data, so training data is different. Now, let me tell you what that number is. Can anyone take a guess? What is 0.829 and why there is a champion icon? Survival? Probability? No. Whose probability? How, which accuracy? Very close, not R square, very close. Anything else? P value, okay, good guess. Anything else? Yes, I agree. If it is near to one, you're looking at a bang on fantastic model that you ran, but there is a meaning to that 0.829. Let me tell you, what is that 0.829? It was the answer to your question. She was asking, why did we give test data at this stage? You know what it did in 5 seconds? It ran the model, it got the equation, it put the equation in your test data. How many rows were there in test data? 173. It predicted survived or not survived in all the 173 rows. One on one, it compared algorithm's prediction versus actual 0 or 1. And in 82.9% of the rows, the prediction matched. Which is fantastic, which means 80 percentage of 173 rows, the algorithm's prediction and the actual answer was actually matching. And that tells you how strong a model without doing anything. We haven't done much of experiment. Even without doing anything, I have achieved 80% accuracy. So within this 5 seconds, all the drama has already happened, which would take 1 hour in coding. So in coding, you do the algorithm first, then you plug in the test data, then you compare yourself with formula, how many matched, how many did not. Here, everything done and dusted. It already took your test data, and I'll show you. You can actually go to the backend, see the prediction for all the 173 rows, see what the algorithm predicted, see what the actual answer was. And in this case, I can say 82.9, which is roughly 83 percentage of my test data. Algorithm's prediction matched the actual prediction. With all the randomness that we have, anyone got higher accuracy? All of you got lower than 82.9. Same. See, almost, and that also shows how generic this model is. In spite of having a sort of different test and train, roughly the accuracy is remaining the same, which is quite fantastic. That is first. My eyes will go on that. Just imagine if we were running 3 algorithms together. If I was running decision tree as well as random forest. For all 3 algorithms, it would have given you this number. And that tells you, oh, logistic regression is working out better. In this case, decision tree is not working out very, very well. At one snapshot with accuracy, you get to know what is working well, what is not working well. Number one. Number two, by the way, we haven't got inside the results yet. This is just surface level results. Number two, that I will keep an eye on is this. What are the most important variables out of all the 10 variables that you took? What are the top 3 variables which are influencing the survival. What are the top three variables? Gender, P class, and age, which was quite matching the hypothesis, right? We saw how influential P class was, how influential gender was, how influential age was, and you can see everything else below that does not matter. Quick question. Let's see who's smart enough to answer this. How did data IQ come to know those top three variables? And you should be able to answer this. How did data IQ come to know of that top three variables? Very easy question if you think. Okay, agree. Anything else? So imagine this tool was not there. Data IQ was not there. And you ran logistic regression.
Coefficient of these three.
100%. Beautiful answer. The coefficient in the equation, you remember something x1 plus something x2 minus something x3? That something is your importance of the features. And you might ask, where do I see that? Something. Where do I see the coefficients? Remember, we have not got inside the results yet. This is only a surface level results. Once I show you what's happening inside the results, you can do a full PhD. You can have everything that you need. You will have the coefficients, you will have the regression coefficient, you will have the error term, you will have the accuracy, you will have something called confusion matrix. You will have everything that you need. But at this level, I can say the top three variables are gender, P class, and age. So what do you think? Brilliant. Yeah, fantastic answer. Yeah. You remember we had that conversation on why is something x1 plus something x2 plus something x3. And I asked you which variable is the most important, and you saw the previous sales coefficient was 5.5, and you said because it impacts 5.5 times, it is the most important variable. So those are coming from those coefficients. I can actually take you to the PowerPoint presentation. You remember this example? Yeah, this is what it is. So based on 2, -3, 4, and 5.5, it picked out which one is there. By the way, this is regression equation. The ideal equation that you should be seeing is this one. So based on beta 1, beta 2, beta 3, it is predicting in which case the probability impact will be higher. So it orders based on that. Okay. All right. Now we are still on surface level results. Let's get inside the beautiful world of logistic regression. Before that, questions.
So, the question tells it like the which you told back is not
Correct.
a good fit for
Correct.
but still then in the equation
Very good question. Your name?
Aditya.
Aditya. Now, this is how an analyst should think. Now you should say that, okay, I'm getting this. I understand that gender, P class, and age are very important. Probably still SP, but definitely not embarked and parents and children. Okay. Now the analyst inside you should be tempting you to say, what if I run it once more? This time without embarked. That's my trial too. Now, if I run it without embark, will my accuracy improve? Will my accuracy reduce? Will it make any difference in the other coefficients? That's how you keep. And this is where, there is no end to this, right? I cannot say I'm done and dusted. This is how an analyst will run trial and errors, will compare the results, will see in which case the hypothesis matches, and finally will decide in which case an analyst is satisfied. So that's a great point. Now I have included embark. What happens when I exclude embark? Or will it affect anything? Will it be the same? If there is a possibility, it might remain the same because anyway it's not affecting much, so it does not alter anything. But if that was troubling, then removal of that can help you improve the accuracy. Could happen, could not happen, but I will give it a try. And that's a great way to think. Okay. What else? Good enough for the surface level. Now let's dig deeper. And this is exactly what you need to do for every algorithm. You shouldn't be satisfied with the outermost results. You should get inside. You should see what is happening in logistic regression. How do we get inside the results? It's very simple. Just click on whichever algorithm you want to get inside. So in this case, logistic regression, just go here and click. And once again, what I want you to do is go back and forth. So for example, right now you are here inside the results. You see this was the name of the analysis. This is the list of models, and you are currently looking at trial one results. If I click on models, it will take me back to this page where I was, outer results. And I can again click on logistic regression, again go back here. If I click on survive model, it will take me back to the actual model. I can also go to visual ML. I can click on survive model. I can get back to this page. If I want to see the results, click on logistic regression, get inside the results page. Get comfortable in what is the result page, what is the outer level results page. This is the result of an individual algorithm, while this is the result of all the trials that you are doing at one go. Okay. So go back and forth. Make sure you get comfortable on where to reach what. So once again, I start from here. And again, I can show you the flow. You see, nothing has changed in the flow. I haven't deployed anything. I'm just trial, trial, trial. I have not made any changes. So I go to Visual ML. I see, okay, this is the name of my overall analysis. Let me click that. I can see the results. Individual results, I can click inside that and arrive at the results of logistic regression. Anyone who has not reached this, I'll give you 1 minute to just, see everything around, go back and forth, see the flow again, make sure nothing has changed in the flow, click on the analysis, go to visual ML again, get to this, come out of this, get that navigation clear so that you know where you are. And finally, land up on this page. Everyone good? Shall we get started? Now let's see some mind-blowing things. And truly, you will be amazed to see what data IQ is doing for you. Should I show the most interesting feature first or last? First. All right. The most mind-blowing feature that you would ever see, which would take probably multiple days to code that in a coding environment, is a feature which is called what if analysis. Click on that and I'll show you what a mind-blowing feature this is. So click on what if, wait for the graph to load and make sure your graph is loaded. Can everyone put this on your screen? Just click on what if analysis. You will see some graph. Yeah. Okay. Now, everyone pay attention on what a feature this is. Now, what data IQ is telling you is you can make a hypothetical customer, or sorry, in this case, passenger. You can have a hypothetical passenger. Tell me the details of the passenger live, and I will do a live prediction then and there itself. Okay. For example, let's say the gender of the passenger is female. Change it to female. The class in which the passenger is traveling is class 1. Let's make it class 1. Let's say the age, and you can actually click on the edit button and put the actual age. Let's say age is 35. Let's say they are traveling with 0 siblings and spouse. Let's say the embarked is S, and let's say they are traveling with 1 parents and children. Give any hypothetical data. Now, as soon as you give this hypothetical data, this is your live prediction based on the model that it ran. So based on this profile of a passenger who is a female traveling in class 1 has the age of 35, there is a 93.2 percentage chance that this passenger will survive the disaster. Look at that. Probability of 1 is 93.24, and it also gives you the prediction. It says the prediction for this passenger is 1, not 0, which means the final prediction is that the passenger would survive. However, remember, this prediction of 1 is based on a probability cutoff, which you can change, which data I use, assuming I think 0.5 or 0.45 to be default, but that's a live predictor. Now, what I can do is change this passenger to the other end. Okay. Right now, this passenger is on survival end, which means there's a 90 plus chance that this passenger will survive. And I know how to make it the other way. Can you tell me what profile should I change? Male. So let's do male and let's do a class of 3. And there you go. A male passenger traveling in class 3 with all the other attributes remaining the same, there is only a 12% chance of survival. And the final prediction for this passenger is 0. And this is fantastic. I mean, if you have a dashboard like this, a new customer is coming in, plug in the data of the new customer, new passenger, see the live prediction, take actions.
So what is that, the most essential feature of?
So this I will explain in the explainability, which is basically based on the coefficient again. So for this particular profile, mostly again, it is gender, class, and age are the top 3. And I'll explain the green and the red code also. And if I have to answer your question right now, I can say that gender is working against the odds of survival in this case. Class, because they are in class 3, is also working against. Age is also slightly working against the favor. But I'll come to that part later. So this is the best feature where you can do live predictions. I can give you any customer, any passenger. You can plug in the data and you can do live predictions. Feature number 1. What else can we check? Let's get to explainability of the model. And this is very important. Let's click on feature importance. This is what you saw in the outer snapshot also, that gender is important, P class is important. But what takes me to a technical perspective is regression coefficients. Now we get the exact value of beta 1, beta 2, beta 3, and look at how we interpret. Stay with me on this. This is very, very important. Now, let's look at, I'll give a more simple explanation to start with. Let's look at age. Okay. What's the coefficient of age? Minus 0.0364. How do you explain it to a layman? Yes, Brenda.
When age, with all other variables constant, when the age of a passenger increases by 1, or probability of the survival increases by 1.
Fantastic. Now this is best explanation. When age increases by 1 unit, the probability of survival reduces not too much, but slightly, which is 0.0388. And that's why you see a red indicator, because it's a negative coefficient. It's reducing your probability. Now, let's read few others. Because the numerical interpretation is a bit different from categorical interpretation, let's move on to categorical interpretation. Now, have a look. Gender, male, coefficient is minus 2.4. Anyone other than Brinda can give me a layman explanation? How do I explain this to someone? What is the gender male minus 2 point something? How do I read it out? Compared to whom? That's the important part. You see, gender female is missing from the list, which means that's the base point of comparison. So how do I read this? Compared to female, if you are a male, your chances of survival goes down 2 2.5 times compared to a female who has a benchmark of 1 as, let's say, the coefficient. So compared to females, male, if you are, then it reduces your probability by 2.5 times, and you see a bigger red indicator out there. Let's look at class 1, or rather the variable P class. Which one do you think it has considered as the base class? P class 2, that's missing. You see, P class 2 is missing. So, how do I read P class 3? Compared to P class 2, if you are in 3, your chances of survival goes down by 0.9. Compared to P class 2, if you are in class 1, your chances of survival is going up by 1.1 times. That's why you see a green over there. So green are the positive coefficients, red are the negative coefficients. Now, let me tell you how an analyst would think about this. All this looks good. Age, on the other hand, looks slightly tricky to me. And I'll tell you why. Because while age, it is showing that as age increases, the probability will go down. But you see, that number is pretty small, 0.03. And listen to it very carefully. What I'm trying to say, if that 0.03 was minus 0.02, or if it was 0.01, or if it was 0, it could have completely changed the interpretation, right? Assume it was plus 0.01. And now I would be saying if age increases by 1 unit, your chances of survival are going up. Now, this is a big dilemma. I mean, age we understand is important variable, but that coefficient with a negative sign is too low a number, because few data here and there, it could actually go to the other end and change the meaning completely. And this is where you will think probably something is happening here. Maybe as age increases, there is a chance that your survival is going down because maybe kids were given preference. But maybe there is a chance senior citizen, maybe after 50, 55, your distribution changes. Maybe they were given a preference, and if you are above 55, then your chances of survival are going higher. You never know. And there is only one thing that can help us examine this better. What is that one thing? Categories. And this is why we made categories. Now, instead of taking age as a number, in your next trial, if you try with categories, probably that can give you a better answer on whether that senior citizen thing was actually happening or you're just thinking out of the blue. So that's a second trial experiment that I will do. But I would take note as these numbers. I will interpret, I will understand what is positively contributing, what is negatively contributing, match my hypothesis with that, and then take an informed decision. Which is even more surprising, that even though the coefficient is so low, but there is still a good importance, it shows something is tricky. And maybe what we are thinking is right, and age categories can be something interesting. So again, that's a great point, great thing to look at, that, it's not that the importance was only 5% or 4% that I can completely ignore. It is looking okay, important, but then the coefficient is looking very, very minor. There's some investigation that needs to be done. Go ahead. Yeah, so intercept is basically a constant. When all the independent variables are 0, where does the survival begin with? So usually we don't spend time interpreting whether the constant is positive, negative. It's just where in the chart it starts its journey. So no need to worry too much about the coefficient. What else? One more important thing. Of course, as I said, you have all the analysis of the world, it gives nice interpretation for everything. Let's look at the most important ones. This one. Confusion matrix. Perhaps the most important piece of information when you look at accuracy. Can everyone see this? Yeah. All right. Now, How do I read this? Can anyone tell me what is happening here in this matrix? What is this 178? First of all, it says total 178. That's your test data. The number of rows in your test. Again, answering your question, it took your test data, it applied it on the test data, it compared the results also. Now, observe carefully. How do I read this? The actual answer was 1 in the test data, and the predicted value was also 1. There were 57 such cases. Okay. The actual answer was 0. The predicted answer was also 0. There were 84 such cases, which means 84 plus 57 out of 178 were the correct predictions, and that leads to 82.9% accuracy. If someone is asking you how many wrong predictions did we get, how would you answer that? 25 plus 12. Those were the wrong predictions. And in your coursework too, you have to be a bit careful here. Now, what can happen is overall accuracy looks 99%. You'll say, oh wow, I got a 99% accuracy. But there is a chance that, let's say, everything was being predicted as 1 and actual was also 1. There are very few cases in the 0, and still the accuracy remains the same. And you have to be careful whether it is overfitting that is causing accuracy or the distribution looks good. So in this case, the distribution looks good, because of which all these scores look good as well. So I would keep an eye on this matrix to make sure I'm not getting blinded by the number in the accuracy. It is predicting good number of cases in 1, it is predicting some cases in 0. There are some misclassifications of 0, 1. There are some misclassifications of 1, 0. It looks a fairly generic model which could work on unknown data also. So I'll be pretty happy with that result. Okay. Any questions so far? All good? Yeah. So that's a good question. And so F1 score actually is based on the calculation of the matrix. So basically there are formulas like true positive divided by true positive plus true negative, etc., etc. But essentially your F1 score can take a hit if majority of your predictions are 1, 1. So what they're saying, don't look at the accuracy alone. Look at all these which are computed from this. Eventually all these scores are computed from here. So if everything looks above 70%, you are quite decent. But let's say if everything is here, your accuracy might be 90, your F1 score could be 30%, and then you see something is a problem. So just make sure that all these are eventually calculated from here. I'm not getting into the formulas, but all of these are calculated from the matrix to see if proper distribution exists and it's not overfitting. That's how you would interpret all this. But there are formulas for all 4, and you don't need the tool. You can apply the formula in the matrix and you can actually compute all these scores. Any other questions so far? Shall we go and check the test data? And if you want to see what is happening in my test data, but before that, there is one piece of information on this screen. Let me check if you can identify. What's the probability benchmark that Data IQ has kept for classifying something as 1, for classifying something as 0? There you go on top. Correct. That's the default that Data IQ has assumed. You can challenge that and you can say, I don't want any sort of biasness here. I'll keep it simple. I'll keep it 0.5, let's say. Yes, the accuracy will change, the calculations will change, but depending on the use case, you can play with that probability benchmark. But you shouldn't play with keeping something like 0.7 or 0.8. That doesn't make any sense. Anything between 0.4 and 0.6 is the gray area that you can try, check if it's affecting your accuracy or not. So usually what it does, it chooses that one range where maximum accuracy can be achieved, but you can change that at any point of time. What next? Click on predicted data. That's where your test data actually is. just right on top, you are seeing report so far. Just next to the report is predicted data. And this is your entire history of what is happening. So first of all, check if there are 178 rows. That were the number of rows in the test data. Scroll all the way till the end and you see what the algorithm has done. For every single row, it has calculated the probability of 0, it has calculated the probability of 1, and it has given the prediction of whether this is survived or not survived, and whether that prediction was correct or not correct. It has added all the information that you need. And in the hackathon, I could actually ask you this. I can say, can you go to the fifth row or fifth passenger in this Titanic and tell me what was the algorithm's prediction, what was the actual answer, and was it correct or not? So you can go to the predicted data, you can see your fifth passenger, you can see what the algorithm predicted, whether it was correct or not. And these columns never existed before. It has added these columns. It has given the prediction 0 and 1 both are not needed because the total is just 1. So actually probability of 1 is all what you need. This is 1 minus that, and then the prediction based on the cutoff, and then whether the prediction was correct or not. It adds all that piece of information to anyone who wants to see it. For anyone who doesn't want to see, you can come back to the report and say, okay, I understood what is happening, but I can go to the test data and I can see what it did at the backend. So these are the things that you must be comfortable with. Number one, what if analysis? You should be able to put a hypothetical passenger, get the prediction, feature importance, regression coefficients, confusion matrix, and predicted data. And everything else is optional. You can see what these are, advanced mathematical parameters, but this is good enough to make sense of a prediction model. Any questions? All good? Okay, so time for us to take a break. It's 2:50, 3:05. We'll be back. Thank you.
Sir,
Yes,
I wanted to ask regarding the mock hackathon when
Mhm.
it's going to be on the 15th,
That's right. For you, it's going to be 15th and the main hackathon on Sunday, 19th.
19th.
Yeah,
So this 15th is the mock hackathon, right?
that's correct.
Uh, but will it be a practice? What is it going to be?
So it will mimic completely the main hackathon. So you'll be given 3 hours, you'll be given data set, you'll be given a question, you'll be doing this. So it will be a complete mock experience of the actual hackathon.
Ah, I see. Okay, thank you.
Okay. All right. Sahil, go ahead.
Hello, sir.
Yep.
So actually, I tried accessing the video recordings yesterday, but I wasn't able to do that. So like it
Okay.
was
Can I
telling,
tell you after the session? You just remind me and I'll show you where it is.
no, sir, I
Hmm.
actually did it, but
Okay.
it was showing that I don't have the permission to access it.
Maybe you are logging in with different ID. You should log in with M00.
So it's the same one.
I can check. So after the session, just show me where it shows.
Okay, okay, sure,
Okay.
sir.
Other students, I'll just take your questions after the session. If you don't mind, we'll have enough time. Thank you.